What's up peeps, Sane Scientist here, and this episode I've got probably one of the coolest things I have ever made. You may have seen this sort of half-built-ish in a previous video. This little devious contraption, which is for this. Should be pretty obvious what I'm making. If it's not, ask someone intelligent. But now it's done, and I cannot wait to show you this. It is absolutely awesome. This is probably one of the longest projects I have ever made. It's taken over 15 weeks to complete. I actually did get it working a few weeks ago, and I've been riding it around just to get places. And it is, of course, an electric skateboard. The idea here was to make the best electric skateboard I could make for the price, and then things kind of got out of hand, and I ended up trying to make a better electric skateboard than the best you can buy for cheaper than the cheapest you can buy, and I kind of succeeded. I will go into this in more depth later, but first I just want to apologize. I haven't slept in more than 24 hours, and I've had 6 coffees alone this morning. Yeah, I just went and drank 6 more coffees for the video, so I've now had 12 coffees, and I'm a little bit hyper. Given that I have been up for more than 24 hours now without sleeping, I apologize for my hair, my clothes, and my general ineptitude as a human being. But anyway, back on topic. I've got this amazing board to show you this video, and I need to head into the shops to get some parts for a future video I'm currently making for a past project. It makes sense, I'm not explaining it. So I thought that'd be the perfect chance to take this out, get some footage with it, put it through its paces, and I promised the people at the store I bought most of the components from, which is J-Car Electronics, that when I finished it, I would take it in and show them. So I'm going to be doing that at some point, hopefully, as well. Now, it's currently 7:30, and their store opens at 8:30, which gives me about an hour until I can even be there. So, I'm going to go through some of the basic features of this, and show you why I think it's so cool. First off, I wanted to make sure this board was as useful as possible, and has a lot of features that you just don't get on a regular board. For example, you can only turn it on with a key. Now, a lot of electric skateboards, you turn on with a switch, and if you have the remote, you can ride them. Some of them even have a pressure pad you can just stand on and take off, so anyone can take it. This actually uses a key. I've no idea where the key is, but it uses one. Secondly, I come home late at night a lot, and I need a torch. Getting your phone out, turning your torch on, it's effort. I'd much rather be able to do this. I have installed 2 super bright LEDs. They're the brightest ones you can buy on the market in the front truck. Now they are wired internally to this front battery and controlled by this switch here. I have actually inlaid all of the wiring on this board into the deck, so I don't have to deal with cable management. And thirdly, my favorite feature, I'm fairly proud of it, I was thinking, what is an electric skateboard? It's basically a giant power bank on wheels. So I made it one. I can charge my phone off this. I can charge the remote for this off this. You can charge anything that uses a USB port. Something I found stupid about a lot of the really expensive boards you can buy, they have an enormous capacity, something like 10,000 milliamp hours, and you can only use it for riding around. The amount of times I've needed to charge my phone and not had a power bank with me, but had my skateboard with me, now I've got one. Observe. I can charge my phone off my skateboard. Now, the remote for this board, I 3D printed. Look, it's fully 3D printed. It has a little roller to control speed. Down is faster, up is slower, and it does have a brake. I will go into the details, like I said, later on. Now, even though I put a wrist strap on this, I kind of didn't use it. And I put this on because the roller to control speed isn't spring-loaded. So if you drop this at full speed, you're stuck at full speed, which is an issue. Which is also exactly what happened to me about the 3rd time I rode this thing. It didn't end well. Anyway, I think it's about time to head off now. Like I said, I'll go into the technical specs when I get back, but for now, let's go. In
the board I've been working on this whole time.
Oh wow. Nice. Harry, let's show you skateboard.
That went well. I got 250 grams of black PLA for the next project, and I'm just on my way to the hobby store, and then I'll be heading home.
Alright, I'm back now in my workshop. I got all the stuff I need for the next project. I'm going to go through the technical specs of this now, and I think the first thing I should start with is the boot sequence, how to turn it on. So first of all, roll this wheel all the way toward the back of the controller and turn it on. It beeps and the light flashes red and green, and after rolling it all the way to the top, solid green. And that means it's calibrated the high point and low point. Then, where's the key gone? Key. When I turn this key, this will pulse for a second, and when the receiver boots up, it'll shut down. So the board is calibrated and ready to go. Then rolling back on the wheel slightly, you'll see the back wheel start to turn, and it is quite loud. So I'm going to keep rolling this up until full power, and then turn it off. So yeah, it's got a bit of kick to it. Technical specs. Alright, all these batteries are 6 volts each. The entire board is 18 volt. These are all run in series. The light at the front, these are 2 lights, they're 3 volt LEDs, and they're hooked up to this battery at the front. They don't draw much current though, so you can run them while you're running the motor, and it seems to work fine. There's 2 LM3 170 voltage regulator circuits in this, which I bought from JCar Electronics. I could have made them, but I couldn't be bothered. One is feeding 6 volts to the receiver, and the other one is feeding 5 volts to that charging port, which is the standard voltage for pretty much everything, any mobile device to charge off. There's not enough amperage running through that sort of loop that they're on, though, to power both at the same time, which works out fine, though, because I don't know why you'd want to be charging your phone while you're riding the board. That would not end well. They say don't text and drive. I'm going to say don't text and ride. This thing is, it's fairly fast. I will be doing some speed tests later with a GPS app on my phone to test the exact top speed of this thing. Oh, by the way, all these batteries are 4.5 amp hour, and since they're in series, the amp hourage stays the same, and only the voltage increases. If I had them hooked up in parallel, then the the capacity would increase. This gearbox contraption in the back looks fairly nice because I've sanded it and painted it, but it is an abomination. It's the gearbox from one drill, with the motor from a second drill, with the stainless steel planetary gears of a third drill. This is the smallest disc from a mountain bike cassette, I think it's called, which is sort of that stack of different sized gears on the back wheel of a mountain bike, or any bike with gears, and that's been welded to a custom sort of fitting that I lathed on my school lathe. I've been working on this so long, I've graduated since I've been working on this, but luckily I still had access to the school lathe when I needed to make that, so that's been all welded together, so that's super strong, that should never break. I put a stainless steel bolt in the back here because the one that it came with on this end was too short once I had this bracket on here. This actually goes around that bolt. All the wiring on here, I'll put a picture up on the screen now. It used to be 15 amp, 50 volt rated wire, and it melted. This motor draws so much current, it melted the wire, and that did not end well, actually. It really did not end well. I burnt out a receiver. I have never burnt out a receiver in my life until this project. I've burnt out 6 receivers on this project. 6! 2 of those cost $70. Oh, by the way, the price of this thing that I'm going to state later in the video is not the price that it costs to build, it's the price of everything on the board. So if you made it, or if I made it knowing exactly all the parts I needed and hadn't burnt out components, broken components, bought stuff I didn't need, that's the price that I'm going to be stating for the price of the board, not what it cost me, because I burned out so many components, I broke so much stuff, I ended up not using a lot of stuff, and that was all in the prototyping phases. Back to the board. All these brackets for the batteries, these are just mild steel that I have bent in a vise and welded and then, sanded smooth, polished up on a wire wheel, and then sprayed with like 4 coats, I think, of rust guard, so they should never rust. all the batteries on this are suspended by fairly soft foam on either side, on the board side and on the bracket side, not on the left and right side because they shouldn't be getting knocked around that way, but that's in case I go over any hard bumps or off a curb. I don't want it to crack the plastic case of the batteries, so I've insulated them with foam, so they're nice and safe. Like I said before, I cut a groove down the middle of the board and ran all the wiring through that. The ESC, okay, now the ESC that runs this thing, I don't know what its max current rating is, but put it this way, I couldn't find an affordable ESC on the market that could handle the amount of current this thing was pulling. Oh, that reminds me, the thickness of the wire. The thickness of the wire I had on here, like I said before, was 15 amp, 50 volt rated wire. This stuff, the new stuff I've got on here, this is 25 amp, 240 volt rated wire, and this seems to be doing fine. But yeah, I couldn't find an ESC big enough, so what I did was, I pulled the transistor out of a 22 volt drill and sort of modified it into a very, very sketchy ESC that I've made. It's actually using a servo to move a variable resistor controlling the gate and drain pins of the transistor that I pulled from that 22 volt drill, and that is sort of limiting the amount of current going to this. The problem was in the beginning that this main switch here, I had this originally, and this is a 240 volt switch. It melted. So I got another one that was rated for 100 amps at 240 volt. I didn't even know that there was a massive switch. It was like a quarter of the size of this box here. It melted as well, and that was just a toggle switch, so I kept on accidentally turning it on. So what I had to do was, I had to do some sort of clever engineering around that. Now, anyone who isn't interested in the very specific technological sort of aspects of this, or doesn't understand sort of technological terms, I recommend skipping to this time in the video that I'm going to put right here, because I'm going to explain how I made that, and you probably won't understand any of it if you're not sort of a techie. So the way I got around this was, as any techie will know, when a transistor has 0 voltage to the gate pin, it'll act as a resistor of infinite resistance. It's an open switch, but luckily that can handle the voltage and the current being passed through it. That's just connected to a variable resistor controlling the voltage to the gate pin that's actually being moved by a servo. Now the reason I did that was I couldn't find any safe way of using the voltage from a smaller ESC or something to control that gate to drain voltage on the transistor, so I made the receiver on a completely different circuit. I did initially try to actually do that, put them on the same circuit and control it completely digitally. I burnt out 3 receivers that way before I learnt my lesson, and ended up burning out another 3 even after I started using the servo method for various reasons. One of those reasons was, like I said, the wire melted, and it crossed that wire snaked all through this power box here, and it melted onto every other wire and just shorted out pretty much everything. Luckily, the main transistor was still fine. It kind of just lost power. So what I did was, I made that switch only control power to the receiver, which is 6 volts at about 0.5 amps, if that. That then controls the servo, and every time I turn it off, I make sure the servo is in complete reverse position, and what that does is it makes the transistor an open switch, and that just keeps the motor turned off. So technically, this circuit is always turned on, but it's not drawing any power, and it doesn't let any power through, and so far it's worked perfectly. Welcome back everyone who decided to actually skip me rambling about the technological aspects of this. The chain here, that's just a regular bike chain. This was a $40 board from Kmart. If you're in America, it's kind of like Walmart. I pulled the USB ports from a dead computer I had. These 2 brackets here, these are actually curtain brackets for mounting a curtain bar, but they were the exact same size as the gearbox, so that worked perfectly. Moving on to the remotes. Where has it gone? So this was printed in 3 parts. You have the bottom plate, the middle section here, and the top. Those prints, or at least the middle section and the top, can actually be found in my 3D printing video if you've seen that one. That was actually, that's how long ago I was making this. This transmitter was pulled from a remote that controlled the remote control car that I bought, like I said, cost $70, that controls this receiver. Now the reason that I bought this car 3 times, like I said, I burned out 2 of the receivers, the transmitter for this car was tiny, and I needed that, or actually the transmitter was about the regular size of a transmitter, a pistol grip transmitter, but the chip that controlled it was tiny. It was a little cheap transmitter, it's not exceptionally high quality, but it was perfect for making into a controller this sort of size and shape. And that's why I kept buying it. Plus, I kind of had designed the entire control system around using that exact sort of receiver and transmitter combo. Now this is underpowered, and so is this, but they seem to be running fine. The receiver is supposed to be running 7.2 volt, 7.4 lithium polymer. It's currently running 6, seems to be fine. This is supposed to be running 6 volt, and it's running off 5 volt, and that's actually running a 3.7 volt 1-cell LiPo battery. I believe it's 240 milliamp hour, tiny little thing, and that's going through a 3.7 to 5 volt step-up micro transformer that I have in this that I pulled from a power bank. There you go. So you can buy these cheap little power banks, and normally they'll have a voltage, if you buy a good quality one, they'll have a voltage higher than 5 volt, and they'll step it down. If you buy a cheap one, they usually just have a 3.7 volt LiPo, just a 1-cell, or a very large one though, and that'll be going through a little micro transformer, step-up transformer to 5 volt. I 3D printed a little roller wheel, and that is glued directly to a potentiometer that is glued to the side of the top part of the case here. The motor. Okay, so I started off with this motor, and as you can see, it was tiny. It was a Tamiya TTO1 D-size motor, I believe. It's probably wrong, but I pulled that off an old drift car that I had when I upgraded it to a brushless motor. Next motor that I used was this one. And this was also too small, and I think I actually ended up damaging it because it didn't seem to run properly after I sort of gave it full power for a little while. And then eventually we have this motor that I've got on now. This was out of a massive drill. It didn't actually come with a battery. I bought this from Cash Converters, which is kind of like a second-hand shop, because I only needed the parts. The drill actually was advertised as not working, but that's fine. I only needed the parts, and the motor seems to be running fine. It does draw a little bit more current than it should, but it's an old motor, so you know, it's to be expected. Plus, I got the motor and the various other bits and pieces, including the gearbox, for $10. So I'm not complaining. I sprayed the entire board black. This was actually a really horrible decal before I painted it, and it looks much better now, so that's nice. The original batteries I was going to use. Okay, here is some photos of those batteries. Originally, I was planning on making this fairly light. I was going to use nickel cadmium batteries, which I know aren't that light, but I was only going to use a few of them, just enough to power it, and I was going to spread them out over the board and then bend a piece of plywood, which is where that giant piece of plywood that's been in a few of my videos has come from. And that I was going to sort of bend that over and then glue that along the side, so the batteries were actually encased in the board. That didn't end up working. They just did not have enough power. The reason I'm using lead acid, not LiPos, lead acid batteries are cheap as hell. All of these batteries together, $45. And it's very hard to damage a lead acid battery. LiPos, somewhat explosive, and this board has melted, caught on fire, and exploded, and it's just using lead acid batteries. Luckily, all of those were just from the control box, and the batteries haven't actually exploded yet, but I'm pretty sure I heard one of the batteries sizzling when I was charging it this morning, so I'm going to be testing all these batteries and making sure they're not actually damaged in any way. And now, the big question, how much did this cost? $295. About. It's one of those things, I can't remember every tiny little piece that went into this. Like this bolt at the back, I've got no idea how much that cost. It was probably like a few bucks. But I've sort of rounded everything to the nearest $5. Something costs like $3, I'd round it to $5. Something costs $2, I'd kind of just get rid of it. It should be fairly accurate, but it's not going to be more than $20 off. And I'm not including things like paint and sandpaper, etc. in that, because that's stuff that almost everyone has laying around, and you don't actually need that stuff. I just used it to make it look nice and pretty. So, the downsides. The battery life isn't exceptional, I'll admit. It's only 4.5 amp hours, and you get much larger capacities on some of the more expensive boards, but it's enough to get me to the shops and back, so I'm happy with it. Also, as you will know by now, it is extremely loud. I don't know how companies like Boost It Board and I don't even know any other electric skateboard companies, but I don't know how they keep their boards so quiet. This thing is so loud. I was going to say maybe if they had their motors like sort of in an airtight casing or something like that, but then they'd overheat. So I'm actually not sure. I mean, this actually does have a fan built into the motor. It's got these two massive slits on the side here so that as it spins, it cools itself down, which is great. this motor hasn't actually gotten too warm. I've ridden this around and sort of put my hand on it and it's been fine. It did actually heat up one time, but I was trying to ride it up a hill, so that's probably my fault. That's everything I can actually think of at the moment for this board. If you have any more questions, you want to know how I did anything, put the questions in the description. I'll try and answer them as soon as I can. I can make another video if I get a lot of questions. So I'm going to show a compilation of the build process photos, and then we'll get to cruising and I'll do some speed tests. Enjoy the video.
Enjoyed the video. Let me know if there's any ideas you have for future projects. Stay and sign us out.